If you're going to work with water, you have to know what you're doing. There's a great deal at stake, and safety is crucial. "5,500 kilometers from Lagos, based in a little country called Denmark, are some of the world's leading experts dealing with coastal projects. These specialists, working for DHI, have accumulated their know-how over decades of experience, which has resulted in the collection of huge amounts of data. This data forms the basis for models, both computer-generated and physical models. These models show how nature will act, for example, in connection with harbour and coastal reclamation projects. The models can predict the impact from the forces of nature, in this case, wave forces. So they're a unique tool for being able to make the right decisions, decisions which are sustainable and ultimately save lives. At DHI, Flemming Schluter is responsible for the physical models.
The physical models are important because you cannot calculate everything behind your desk. So in order to be sure that the structures can cope with the forces of nature, then you need a physical model like the one we have got in this laboratory to check the validity of your design.
To ensure the best possible design solution for the revetment at Echo Atlantic City, DHI have produced and worked with two different types of model.
The 2D wave flume test showed that all the three profiles that we tested for the Echo Atlantic project were stable. The third profile was, however, the best one. It was safe and stable.
The 2D tests were done to find out the most suitable cross-section. Different revetment cross-sections were subjected to waves with significant wave heights of between 1 and 4 meters in height. Such wave conditions occur on anything from a monthly basis to once every 100 years. With this information, DHI's Flemming Schluter could start constructing the Echo Atlantic City revetment in a scale of 1 to 45. The large model reproduces all the bathymetry details. The model will show if the revetment can withstand the type of storm that only occurs every 100 years or so. The work has to be very precise. The small stones that are used in the revetment are weighed and sorted. Every detail is considered. 3 weeks intensive work is necessary before the first tests can be done.
The first 3D model test consisted of tests during the construction phase. In this phase, we are testing an unfinished structure where parts of the structure is fully finished and parts of it is not protected by the finishing armor blocks.
It became apparent that the unprotected areas of the revetment were damaged when waves reached a height of 3.4 meters, which happens approximately once a month. Vital information to be aware of when one starts construction of the real revetment.
When the revetment gets damaged during the construction phase, some of the materials will move towards the lee side of the revetment. And in this case, it doesn't actually matter, and it will be easy to continue onwards the work process after a small repair. It's important to emphasize that it's only the unprotected part of the structure that were damaged. The part which is protected by the acrobot blocks are completely safe.
In the final test, the completed revetment survives the type of waves that only occur every 100 years, without any sign of damage.
The tests here at DHI showed that the Echo-Atlantic revetment is a completely safe structure. Even when the model was impacted by waves only occurring every 1,000 years, then it was still a stable and completely safe structure.
So not even the type of storm we only see once every 100 years can affect the construction. Thorough testing and extensive experience from similar projects. Together, all this knowledge and expertise has formed the basis for a revetment design which can withstand the forces of nature. And safety is ensured.